Hey, good morning, everyone. So, Blen is a senior DevOps engineer at ACE. She was kind enough to join us today to share her experience. Today, we'll learn about cloud native DevOps engineering principles, best practice, and standards. Blen, you have the mic.
Okay, thank you everyone for joining us. So I'll be discussing about the DevOps practices on the cloud native environment. So I'll be presenting my slides. We will be discussing mainly about agendas. So I'll be focusing on DevOps practices on the cloud native environment. So some of the practices we have to follow on this era or this cloud native environment. So first of all, let's to discuss the cloud native itself first. So cloud native is the methodology or the development for cloud application in the cloud environment. So modern companies now going to the cloud native environment. So they are using different cloud native or cloud services. So to use these services, we have to involve some cloud adjustments or some employment of tools like containerization is one of the good examples we have for easily packaging our services or distributing our application to the cloud environment. We have to employ different tools. One of the best example I can mention is containerization. So these technologies facilitate rapid adjustment of our application without causing any service disruption or providing a best or a fast business advantage for us, because the easy of deployments are for us will help us deliver the application faster, because when we remember the previous era or the on-premise environment, deployment is very tiresome and very time-taking for all the IT team. So cloud native is going or providing short delivery time for us and very best business advantages to us. So the one we like to discuss is the Cloud Native Computing Foundation. So this foundation is non-profit software organization which is focused on open source product developments for the cloud native technologies. So CNF encourages creativity on the cloud computing environment, so which is normally vendor neutral for any application or for any services. The open source products, which is aimed to develop for cloud native technology, is encouraged by CNF. So the best examples we can mention is Kubernetes, which is open source products developed by the CNF community. So when we go to the main topic of this event, so DevOps is the main topic, and DevOps is, as you all know, just not a tool or a job role. It's so these practices encourage our organization delivery, application delivery. So by providing fast delivery and high velocity deployments, we will be achieving those cultural philosophy and practices on our organization. So the benefit of DevOps engineering is rapid delivery, as we all know. So scalability is one of the good advantages of DevOps engineering, and enhanced security is one of the big advantages. So we can achieve the with DevSecOps engineering principle. So we can achieve enhanced security. And on DevOps principle, one of the big advantages is the team will be working as one, not the separate IT or operation team and dev team. So the team will be joined as one team, and the responsibility. So this will provide us collaboration between our team. So this is the old DevOps principle, but when we come to the cloud native world or the cloud native era, this cloud native architecture enhanced our principle also on the DevOps practices. So the rise of the cloud-native architecture has transformed the whole application development, deployment, and management. So by using cloud-native services and principle, the architecture now will be very scalable and reliable for application deployment, because the cloud services are very easy to scale, and we can monitor the reliability of each services very easily without any hard-coded monitoring or any kind of third-party tool. So this will provide us, our team, more agility. So the contemporary applications are now very easy to deploy and to manage. So these cloud native world now have best practices, which is come together with the principle. So when adapting cloud native DevOps engineering, we require not just to install one specific tool, but we have to follow some discipline and designs for our application deployment, and we have to provide or have a continuous feedback or refinement loop for us. So some of the best practices on the cloud native environment is now developing the application on microservice architecture instead of the monolithic architecture, because the applications now should be very small in size, because each service should have its own functionality, like simple accounting service, simple marketing service should be for one big monolithic ERP system is the best practice now for all cloud native world standard, because of the agility of the team and the fast delivery we require for our products. We have to focus on creating a services on microservice architecture. And when you think of microservice architecture, we have to think of packaging our services on containerization environment for easily deployment and hosting the application on different environment on different services. We have to think of containerization in our mind. So after containerization technology, we have to have one tool, which is container orchestration tool for managing our containerized application. So when we think of container orchestration, one of the big market owner is Kubernetes. So Kubernetes, I mentioned above, the open source product, which is supported or developed by the CNF project or community. So it is the most popular container orchestration tool. We have to think of our container orchestration tool, or we should pick the right tool for our application management or container environment management. So after all this technology, we have to think of infrastructure as a code, because we can't easily manage all this infrastructure and application deployment with our manual setup or manual intervention with human intervention. So we have to focus on packaging our service, application deployment, infrastructure, and everything as infrastructure as a code. So this will help us improve our deployment or our service delivery by automating the infrastructure configuration, provisioning easily from our version control system. So when we think of version control system, there is always a principle or practice comes with the version control system, which is in DevOps practice, one of the main agenda is continuous integration and continuous deployment. So when we have application deployment in line, when we have infrastructure as a code, as a principle, we have to have continuous integration and continuous deployment as one of the core principles of this cloud native deployment. So we have to deploy our application from our CI/CD pipeline, and we have to manage our infrastructure as a code from the CI/CD pipeline itself. So we have to think of monitoring our application from the cloud native environment. So we have to monitor our application performance. We have to monitor our infrastructure performance from different monitoring tools like Prometheus. So we have to observe if there is any issue or any error on our application. we have to observe with the help of, for example, Grafana and Prometheus, a combination of monitoring and observation tool. We have to think of Datadog, or in different options are there for the market. So we have to think of focusing or monitoring and observation is the best practice of one of the cloud native era here on our DevOps principles. So the best practice is one of the common best practices of having the security in line, because when we set up infrastructure and application deployment, there is always one or more issues, which is the best and the common principle is to have a security in line from infrastructure as a code to the application deployment. We have to secure our code, so we have to do sanity check or security check on our CI/CD pipeline. So security should be integrated with the CI/CD pipeline. This is one of the DevSecOps principle. So we have to think of security as a serious or a core principle here. And after that, the automatic testing is just one of the practices. And also, like I mentioned previously, the CI/CD pipeline should integrate the automated testing. So if we use automated testing, or if you have a test plan or a test files already developed for our application, so we have to integrate that in the CI/CD pipeline. And finally, when we finish all of this, we have to do cost optimization on our cloud services, because if we let our services scale without any required specific requirements, so the cost will be very high. So we have to optimize the cost every time based on our load on our microservices or on our application. So cost optimization is one of the required principle or the required practices we have. So let's go to deep dive on the CI/CD pipeline, because it is the core principle we have. And as we all know, CI/CD is continuous integration and continuous deployment or continuous delivery pipeline. So these pipelines are automated process for us to integrate our tests, to integrate our code, test and deploy the code efficiently and reliably. So the well-designed CI/CD pipeline standardize our workflow. So the minimum human intervention is the best for our application deployment, because if we have maximum or a big human intervention, for example, when we have a dev environment and when we wait for the manual approval for deploying application to the dev environment, it's very tiresome and time taking. So we have to automate as many times we can. The UAT QA staging should be automated, but we have to focus some kind of manual intervention when we go to the production environment. So CI/CD pipeline is aimed for us, or the principle is for us, giving us automated deployment to all environments. And when we mention all environment, we don't focus on production environment, because the humanitarian is required at some point because of the customer or the load on the production environment, or we should focus on manual intervention on the production environment specifically. And when we go to this, which is designed for that provider specifically, so these native designs will help us automate everything using the cloud native or the cloud service pipeline to the same cloud environment. So when we scaling the builds on demand or rolling back failed deployments in a few seconds, the cloud native CI/CD pipeline is the best one for us to use instead of using third-party CI/CD pipeline tool. So when we focus on the CI/CD pipeline, each phase has its own point. So the first point is building our code. So every application which is pushed to the pipeline should be built first. Then it will be continuously testing with our test platforms, like I mentioned earlier. So we have to integrate test platform on our pipeline. So every build should be tested after build completion, and we should plan the release after the test is passing. So the release will be on QA environment or dev environment or staging environment. So this will be specific to each environment. So we will have different stages or different pipeline for each environment. After the release, we have to focus on the release is one of the packaging of the application. So when we mention a release, the application should be packaged on artifacts. So it will be, for example, if it is a .NET application, we have to have .NET packaging on our CI/CD pipeline integrated with that. So we have to package our artifact to that package manager. So if it will be NuGet package manager or npm package manager, so we have to release our packages to that package manager, or we can release our Docker images or to the container registry. So this is the release path. After the release path, we have to go to the deployment, which is deploying to the QA staging and UAT environment. So we can deploy to the container service, we can deploy to the web service directly to the virtual machine. So this is the deployment stage. After deployment, we have to go to the operation, because the application will be used by the clients or the customer on the operation environment, which is the the container service, or which is the virtual machine. We can expose our application to the client and the customer on the operation part. So after that, we have to monitor our application every time, because monitoring is one of the core principles on DevOps or the cloud native DevOps environment. So monitoring should be, like I mentioned earlier, should be managed very seriously by third party tools or cloud services provided to us. So we have to monitor our application performance, we have to monitor our infrastructure performance, and after getting feedback from those monitor services, we have to plan for our changes on our application deployment or on our infrastructure management and infrastructure design. So this is the core principles behind the DevOps pipeline. So when we focus on the cloud native CI/CD pipeline, are designed to take advantage of the scalability of the cloud, which is, for example, when we mention serverless computing environment. So scalability of serverless environment allow us to quickly and easily deploying application to their clients. So our application now doesn't require a specific virtual environment or virtual machine. So we can use any simple services like Lambda app services, and those simple services now scale our production deployment very easy and very fast. So the cloud native is the way to build and run applications that take advantage of scalability and of the cloud computing model, like I mentioned. So the container is one of the good example, and serverless is another example we can mention. So when we talk about the cloud environment, one customer can use multi-clouds, which is one client or one product can use Azure cloud environment, AWS cloud environment, Google cloud environment at the same time. So deploying or packaging our services to all this environment will be very tiresome if we think of deploying the application to virtual machine specifically. So we have to think of another very easy to use services or tools like containers, serverless applications, serverless services, or serverless computing environment, and another which is there are multiple services provided for us. So we can focus on the simplicity and the scale of deployment when you think of cloud native application deployment, or when you think of cloud native CI/CD pipeline. So the CI practice is focused on integrating our build and test on our CI/CD pipeline. The continuous integration is one of the big principles to build and test our artifact or code very easily by automated process. So the cloud native continuous integration is simply continuous integrations that can support cloud services often used in the cloud native development. So the cloud native CI/CD pipeline has different open source projects or supports for by CNF. So Argo is one of the best example for Argo pipeline design. So and Flux, Qt, Open GitOps is the project by CNF, which is similar to GitOps, which is enterprise product. So when you think of the cloud native deployment, you have continuous integration solution for cloud services, which will lead us tools and technologies like container orchestration, like Kubernetes, and the seamless continuous delivery, like Canary deployment. So when we think of container deployment, we have to think of container orchestration inside. So when we think of container orchestration, we are scaling up our deployments very big. So the deployment should be planned very seriously. So we can use Canary deployment for changing our deployment environment smoothly, because when we deploy application or artifact to the production environment directly, there should be some downtime. So to avoid this kind of downtime, you have to think of different deployment strategies like Canary deployment, blue-green deployment to avoid downtime between the deployment process. So the CI tools with the built-in container registry can help us streamline these processes. So like I mentioned, Argo will help us to streamline the CI/CD pipeline on the cloud native environment. So the best example are these, but there are different projects supported by CNF, which is the CI/CD pipeline tools. So the Argo workflow for the Kubernetes environment seems like this, like for simple CI/CD pipeline, which is focused on deploying the application to the Kubernetes environment, is like this. So the Argo workflow is Argo is the open source container native workflow engine, so which is designed mainly for container deployments. So this is one of the good example of the deployment workflow we have on the screenshot. So we can clone the repository first, then build our image, then scan the image we have. So after that, we can scan the case environment we have. So after that, we can deploy our image to the Kubernetes environment. So if you see the diagram below, the first we will do the clone of the codes. Then after that, we will build and push the image to the container registry. After scanning the image, we have to scan Kubernetes manifest and deploy to the cluster. So this is very simple workflow, but the simplicity comes with the Argo native design for Kubernetes or cloud native environment and container deployment. So Argo is the biggest popular or the big market share when we think of deploying our application to Kubernetes environment. So we can see the details on their documentation or on the CNF project documentation. So I can mention one of the biggest market share is Argo on the Kubernetes deployment environment. So we move to after designing CI/CD pipeline, we have to focus on infrastructure as a code, because when we think of deploying application to environment or on premise environment or on cloud environment, we have to think of doing this deployment easy with infrastructure as a code, because manually setting up each service or manually setting up a virtual machine is very tiresome for us. So infrastructure as a code is one of the biggest or core principles beside the DevOps principle, because having template for our infrastructure is very common and standard process now. So for managing our services or creating services very easily, we have to have infrastructure as a code on our version control system. So the commonly used product is Terraform. Terraform is open source infrastructure as a code tool, which is created by HashiCorp, and Terraform enables us infrastructure team to provision, update, and destroy on-premise and cloud infrastructure components like virtual machine, container runtimes, or Kubernetes cluster. So Terraform is very powerful product, which is use declarative languages rather than postural language. So users describe the desire in the state of their infrastructure process. Like, for example, we can set up our EC2 instances. We can set up our networking like VPC, private subnet, public subnet, all on one Terraform module. So Terraform will provide us the state file at the end, so we can easily deploy our code on those environments after running one simple Terraform module. Every infrastructure or every services on the cloud services will be created by Terraform. So Terraform has different stages. There is a plan stage, apply stage, and destroy stage. So when we think of one Terraform application or Terraform module, we have to run the plan first, because when we directly apply the changes, there should be some inconsistency or some error on our um, order or our creation of the services. So we have to focus on first checking the plan of the Terraform before applying those changes directly to production or to the dev environment. So Terraform configuration file should be version controlled. So like I mentioned earlier, we have to always use version control system for managing our infrastructure as a code. And for example, we use Terraform modules or Terraform templates on our GitLab pipeline or GitOps pipeline. So every time when one DevOps engineer changes on one Terraform file, everyone will be notified about that plan. And when we approve the plan, so that DevOps engineer can apply the changes. So this kind of standard should be applied for infrastructure as a code management, because infrastructure as a code is almost a code or software for DevOps engineering, because infrastructure is very serious thing for the DevOps engineering, because when we fail one services on infrastructure side, the application will be failing. So when we cut out something with inappropriate or wrong plan, then the production environment will be affected. So organization use Terraform to provision and manage infrastructure through lifecycle. Commonly for multi-cloud management, Terraform is the best tool for us. And like I mentioned, application infrastructure management is the common uh, use case for Terraform, and we use self-service infrastructure management. And for the team collaboration, like I mentioned earlier, if we have more than one or two DevOps engineer, when we have a bunch of DevOps engineer and infrastructure team, we have to commonly use one infrastructure as a code Git repository, so to manage our infrastructures. So after infrastructure as a code, we have to go deep dive on containerization or container orchestration. So containerization is as a software development toolset. It bundles our application in files, libraries, which is the required packages for running our application on any infrastructure. So this help us portability, scalability, fault tolerance, and agility. So the application which is deployed directly to the web server is depending on the virtual machine, because we have to install each required packages directly to the virtual machine. We have to set up everything manually to that specific machine. But when we package our application to the container the containerization tool, we have to package our package every library's dependencies with that container, so with that image. So this helps us scalability and portability, so we can deploy this application easily on Mac OS, Windows, and Linux. We don't have any dependency with the host environment. Containerization is the biggest technology advantage with packaging application to any environment. So containerization is easy for us to deploy in our application and ship it to any environment. So containerization is isolated for application or services which is dependent on single unit called container image. Yeah. So everything is packaged with the container image. So there is no dependency beside the container image. So you can host application to container services like ECS on AWS. We can run those services with Azure cloud environment, Google cloud environment. So the dependency is just on container runtime or the container image. So hosting application to any environment is very easy and very seamless operation. So this helps us in microservice architecture deployment because containerization is very commonly used with microservices architecture. So when we think of microservice architecture in the multi-cloud deployment, we always use container orchestration as a standard or best practices. So this will help us having good productivity and early application deployment for the team. So when we think of container orchestration, containerization, we have to think of container orchestration. So we can manage our containers when we have one or two containers, but when we have 1,000 and 100 containers, we have to focus on having container orchestration tool on our infrastructure. So container orchestration is the process of automating networking between containers, because when we have containers, for example, when we have a web application running on container environment and when we have a API environment application running on container environment, we have to need have connectivity between them, because the web application will be calling the API service every time. So the connectivity should be managed, the network should be managed by our container orchestration tool. So we can use container orchestration to scale this deployment. When we have one web service and one API service, the user number will be very small. So when we increase our users or clients, we have to have scalable application or scalable deployment on our infrastructure. So container orchestration is one tool which help us scaling our deployments very easily. So microservice architecture have multiple services on it, and those services can be replicated 100 or 1,000 times for manage the required or number of competency with the number of users we have. So this is the most common use case for container orchestration. When we have monolithic application, we don't really use Kubernetes or containerization because of the rigidity of the deployment. Monolithic application is more focused on deploying on application on directly on via virtual machine or on the web servers. But when we come to the microservice architecture, the easy of packaging application or one service to the container help us or force us to use container orchestration tool to manage our services, scalability, manageability, and the whole life cycle. So Kubernetes is one of the biggest market share on the Kubernetes on the orchestration environment. So Kubernetes automate the task of deploying application, managing containerized application, and the whole life cycle. So over time, Kubernetes has become essential for developing application in many areas such as microservices, web application, and databases. So even for stateful application like databases, Kubernetes has support, which is stateful deployment. So when we see the Kubernetes architecture, we have different components inside the Kubernetes control panel, which is etcd, one of the commonly mentioned services, which is key value store or data store for each configuration or file on the Kubernetes environment. There is Kube API server, which is basically managing communication between different components. There are container there are different nodes for each node. There are different components like kubelet, kubeproxy, which is the best services for communicating the control panel with the worker nodes. So this design will explain the whole components we have. Control Cloud Control Manager is the services packaged with Kubernetes environment to manage like load balancer we have and other services provided by the cloud environment. Kube API server is the core services on Kubernetes environment which handle every operation, and Kube Scheduler is one of the services which schedules the deployment of ports to the nodes, and the Kube proxy is for network connection between the control panel, the node, and everything. The network is managed by the kube proxy. Kubelet is the agent which manages nodes, and the nodes will send their state to the kube API server using the agent called kubelet, and kube proxy is also exists on the node side for connecting these nodes to the control panel. So cloud API provider is always connected with the kube cluster or the Kubernetes cluster to send information about the state or the processes the Kubernetes is managing directly. Because when we use Cloud Manager or Cloud Load Balancer, the information should be sent from the cluster to the Cloud API provider directly. So after all these setups, we have to think of observability and monitoring of our services. So after setting up the cloud deployment with Kubernetes, like EKS, AKS, different in native Kubernetes environment or on-premise Kubernetes deployment or another options we have to think of monitoring this environment very closely, because when we have some performance bottleneck on the application or on the infrastructure side, the production will be interrupted very easily. So we have to identify any issues before the issue becomes the blocker for application running or when before the application stops running. So observability is a discipline on software engineering, which is or for system management, because observability is the core principle which help us improve complex system performance. So this principle is designed to help organization monitor, diagnose, optimize their application and infrastructure in the real time. Like I mentioned earlier, we have to monitor our scalability wisely. We have to monitor cost very wisely. We have to monitor the application logs, metrics, and everything very closely because of the importance of the applications provide services to the client directly live every time. We have to monitor them very closely. So observability in the cloud native environment is system property, which is help us with the native application deployed on cloud environment like CloudWatch, Azure Insight. We have to monitor the application or the service health very easily with the help of those kind of services. So we have to monitor CPU time, memory, disk space, and any other application or infrastructure related CPU metrics. So we have to monitor those metrics closely with the help of monitoring tools. So the observability has different metrics, like I mentioned. For when we go to the application observability, we have metrics which is sent by the application, and there are logs generated by the application, and there are traces. There are traces most commonly come with microservices because microservices call each other every time. One service can have different service calls, so we have to track the traces. So when we fail, when one call fails, so we have to follow the trace, and when you should identify which service is failing. So these metrics are the most common one you have to monitor closely. So after monitoring, we have to go to the cloud native security management principle. So cloud native empowers developer to deploy and scale application that can be containerized, reuse, disassemble into self-contained resources efficiently for microservices, and you can use serverless function. So when we deploy application to the container environment or the serverless function, we have to check every time if we have any security bottleneck between them. So we have to do sanity check because there will be cyber crimes for any kind of application we host on the public cloud environment. So when we think of deploying our application, we have to think of how we protect our application. So we have to set up proper firewall, proper web firewall policies and principle, and proper firewall for our network setup. And we have to think of using different kind of prevention for our application to be secure. And so there are different principles in these cloud native approaches, like shift security left, which is from the code level to the infrastructure level, securing infrastructure. When we design our infrastructure as a code, we have to check the security of our infrastructure. We don't have to use directly our secrets or access like password, usernames, or our infrastructure as a code. So we have to manage those on different secret manager besides the infrastructure as a code template. So some people, or on the very beginning of infrastructure as a code principle, use their password or AMI access password or any SSH key on manually on the infrastructure as a code. But now as a standard, we have to do those kind of password management, key management on another secret management manager tool. So the cloud native environment provide us those kind of tools like AWS Secret Manager, Doppler, and different tools are now available for us to manage those kind of very sensitive data. So under we have to have a principle for like role-based access control, and some kind of principle to control our security, and we have to protect our APIs with API gateways in different kind of methods, and we have to encrypt everything. Like when we have used the like SSR packet for different sensitive data, we have to encrypt everything. We have to encrypt our even virtual machines data by encrypting the volume. And there are different methods to encrypt everything we have on our application to avoid cyber crimes. And we have to implement or have a knowledge about implementing security continuously. So DevSecOps help us with this kind of implementation. So we have to integrate every security check on our pipeline with different tools like quality control gates, like different options are available here. And we have to know the shared responsibility for the cloud environment, because some of the obligation is on the user side to have protection, like to encrypt the EC2 instance volume for very sensitive data, to encrypt our S3 bucket for hiding very sensitive data from the client. So we have to know the knowledge of shared responsibility, and we have to protect our data. So I just finished my presentation. If